I'm Molly, or as some of you may know me, I'm 208-97312, and I'm a first-year student in environmental science. And a fun fact about me is I really like metamorphic rocks because, like them, I'm always under pressure. Whoa! What a cool specimen I found! I found this at the beach in Hamilton, Ontario at Hutch's, which is home of the best fish and chips about 3 months ago. Here in the shoreline, it is covered with lots of sedimentary rocks, from boulder-sized grains to clay. According to the Geological Map of Canada, majority of rocks found here are sedimentary. Out of all the rocks there, I chose this lucky guy. It is light gray and very well-rounded with many white, well-rounded clasts in it. It is also very smooth. And based off of these features, I can either have a mineral or a rock. And I have identified this specimen as a rock due to these many features. At first, when looking at this rock, as I mentioned earlier, it is well-rounded and smooth and by the water. I infer that this made me think that it is a sedimentary rock because of the weathering from the water would make it this smooth, round structure. Also, when looking here, you are able to see some layering, which would show that the sediments accumulated over time and then were eventually cemented together. When identifying the grain size, when I rub it, I am able to feel a sandy texture, which helps me identify the grain size as sand. At first, when looking at this rock, I wasn't sure if these white parts were new parts of the rock or discoloration from the low acidity of rain. So to test this, I scraped the rock to see if any white part would come up underneath. As you can see, there is no new white part. And then, also to test, I then poured hydrochloric acid, but I actually don't have hydrochloric acid, so I used white vinegar, and I poured it on top of the gray part of the rock for a while and then wiped it off to see if any lighter color would come up. But it didn't, so we're good to go to say that this has two parts, which means that this rock has a matrix. So, to determine what these white parts are, I went through a mineral identification process and determined that this was calcite. So to test this, I used a copper penny to test the hardness of the calcite, which is a 3. So when I scratch it, you can be able to see that it does scratch the calcite, but you may not be able to see this in the video because I'm filming it with an iPad. So the big test to test if it's calcite is to use hydrochloric acid. But since I don't have hydrochloric acid, I just use vinegar. And as you can see, when I pour it on, it fizzes effervescently. You didn't see it effervesce, so I'll try it again over here. If you can see it. You can see inside. You can see it bubbling. Based off of my mineral test, we have calcite in this rock. And since it also makes sense that there be calcite because this is a sedimentary rock and due to organic material going in. Also, since the calcite has a larger grain size than our gray part, it means that we have a poorly sorted sedimentary rock. And since these class of calcite are well-rounded, it also means that our rock is a conglomerate sedimentary rock. Based off my rock test and mineral test, I have a conglomerate sedimentary rock with calcite clasts in it. And if you want to find a cool rock like this, go down to the beach at Hutch's and have the best fish and chips and find yourself a rock.